Hello, everyone. Welcome to another episode of Math Time with Mr. Schultz. Today, we will be performing operations with functions. So, I will be able to perform operations with functions. Now, what does this mean? Before I continue, make sure you put your name and your period up here, and we'll eventually figure out how many this was. But this will be our first lesson jumping into this. Inquiry question. Do you think that the graph of f of x plus g of x will be more or less steep than the graphs of f of x and g of x? Well, before we dive into this, let's jump over to Desmos and figure out what it's actually asking. So we're going to see, hey, we have our graph g of x right here. Now, if you notice, it's a line because it has a degree of 1. The x has a power of 1 right here. So that means it's going to hit at 0 because it's mx plus b, and it's going to go up 1, 2, 3 over 1. And if we click right there, there's 1 comma 3 right there. So what I'm going to do is I'm going to copy paste. I'm going to post this over here. There's my graph right there. Cool. Now I see my 2x minus 4. All right, well, that looks a little different. Let's see what that looks like. Let's compare them. Hey, it looks like it's less steep. You see the red's going faster than the blue? But the other thing we're going to notice is, hey, it goes down 4. It hits here at 0, negative 4. So let's take that off. We have two different graphs right here working right here. Post it right here. They look similar, but if you notice, the slope of this one would be 3x, and the slope of this one is 2x, meaning 3 over 1 and 2 over 1. All right, well, what if we have one function? What if we add these two functions together? Well, let's see what happens. Make a prediction right now. What do you think it will look like? Do you think it'll be somewhere in between? Test it. We're going to go on in 3, 2, 1. Well, here it is. And if you notice, it's quite steep. We can change this color a little bit if we want. Let's change it to green. So red plus blue will equal this green line. We notice that it has in common, it has the same intercept right there, but the slope is quite different. So why don't we turn these off and photo and put it right here. So the question that we have is, the combined function of f of x plus g of x is more steep or less steep? Go and fill this in and answer the Edpuzzle question that we're going to have. All right, going on. Basically, we are now going to be combining functions in different ways with addition, subtraction, multiplication, and division. So let's dive into it. All right, guys, so if we're going to be adding two different functions, what we're going to be doing is we're going to literally be saying, hey, we're going to add this function with this function. So the definition will look like the following. So here's our definition. We're going to be adding function f and g. So that's literally, we're going to have function f, and we're going to add it to function g. So here's our example. We're going to see that the function function f, is, f of x, is going to equal x minus 1. And we're going to want to add it, or add into it, g of x, which is 5x minus 2. Well, now we just need to put the x's with the x's and the numbers with the numbers. So x plus 5x would give me 6x. And minus 1 minus 2 would give me minus 3. So the f plus g of x will equal 6x minus 3, which makes sense because if we go back to our Desmos activity, we can see that, hey, look, this was 3x, this was 2x. If we add those together, that would be 5x. And that would make this green graph really steep. All right, well, let's jump and do subtraction. So I'm going to pause it, and then you can write down the definition. All right, so we have f minus g of x will equal f of x minus g of x. So that's pretty much what we're going to take one of our functions and we're going to subtract the other one. So I'm going to put this here and I'm going to put this minus sign right here. And now we have to remember we're going to have to distribute this minus all the way across. And we have this 5x minus 2. So that means this becomes later. Let's make it green. This is going to become minus, and this is going to become plus later. And this will cancel out. So x minus 5x would be 4x. But wait, did you catch it? Yeah, that's right. It should be negative 4x. And negative 1 plus 2 would be plus 1. So this function would equal negative 4x plus 1. And just remember to put the x's with the x's, the numbers with the numbers, and the x squareds with the x squareds. This next one we have kind of looks like this. We're going to be showing that we're going to multiply one function to another function. So we're going to be multiplying f of x to g of x. So what this looks like is we're going to take f of x and multiply it to g of x. Now, since it's two binomials, I'm going to want to draw a 2 by 2 grid. So I'm going to draw it out and then unpause it. Okay, here we go. So we have 5x times x is 5x squared. X times negative 2 would be negative 2x. 5x times negative 1 would be negative 5x. And negative 1 times negative 2 is 2. And so if we combine these out, we should get 5x squared minus 7x plus 2 because we are combining like terms and we don't do anything else. Now, the funny thing is, both of these should have been lines because they're in 1 degree. They look like lines. But now that since it's in the second degree, it's going to look like a quadratic. It's going to look like a parabola. All right, let's dive into the last one. We're going to have division. So pause. So the only thing different for this one is we have f of x divided by g of x. But g of x can't equal 0 because you can't divide by 0. So writing like this, we have x minus 1 over 5x minus 2, but we can't have x equal to 2/5. Because if x equals 2/5, then the bottom part, the denominator, will equal 0, and we can't have that. All right, let's do some example problems. So we literally just did some of this, but let's jump in and see how fast we can do this. So I understand that I'm going to be adding these. So I'm going to be adding f of x. So this is going to be equal to f of x plus g of x. So now I'm going to add negative x squared plus 3x plus 1. And I'm going to add it to 2x squared minus 5. So I'm going to put the x squareds together. I'm going to put the numbers together, and there's no x. So I'm going to leave them alone. 2x squared minus x squared will give me x squared. 1 minus 5 would give me negative 4. And hey, this guy's going to come down, and now he's just plus 3x. So f plus g of x will equal x squared plus 3x minus 4. That's it. Just combine like terms, and you're good. Now, subtraction is going to be a little bit more difficult because you have to remember you're going to distribute a negative across the parentheses. So I have negative x squared plus 3x plus 1. I have this minus 2x squared minus 5. So I like to change color and I'll say, hey, this is going to become minus, this is going to become plus, and this guy cancels out. So now I just combine like terms like I did previously. So negative, negative will still be negative, but now it's 3x squared. This 3x is still there all alone, and 1 plus 5 is plus 6. So f minus the function f minus the function g of x will equal this. And let's go on. Now what I want you to do is I want you to try to do this multiplication and division, and then I'm going to do it. So I'm going to pause and do multiplication in 3, 2, 1. All right, so I've set up the problem. Now go ahead and try and do it as we dive into this, okay? So multiplying it out, I'm going to get negative 4x cubed minus 2x squared minus 3x, and then 4 times 5 is 20x squared, negative 10x, and 5 times 3 is 15. Now I'm going to circle what they have in common. These are the same. They both have x squareds. And then these are the same. They both only have 1 degree of x. Everything else is by itself. So now I just need to combine those and I'll be good to go. So this will equal negative 4x cubed plus 18x squared minus 13x plus 15. All right, let's try the next one. Once again, I want you to try it and then we can correct it. In 3, 2, 1. All right, so you might be like, wait a second, we're done? Well, yeah, yes and no. We also have to make sure that we understand that x cannot equal 5. Let's actually look to see what this actually looks like. Let's go to Desmos. So I'm going to plug I've already plugged this in, and you can see that it kind of looks like a parabola right here. But you'll also see that, hey, wait a second here. What's happening here? If you look, it makes like a little asymptote right here. That means like we can go forever this way, we can go forever this way, and we keep going to the right here. It's going to get really close to a number. Look, it got to 4.77. So now if I go this way, let's say I go this way, it's going to get really close to another number. Hey, look, it's at 5.65 right now. But I wonder what number it's going to deal with. I wonder what number it doesn't want to be. If you remember, we don't want to have x equals 5. So in this case, every number is going to be, you can input all values except for x equals 5. It makes like a limit. As x approaches 5, it's going to get, as it approaches it from the negative side, it's going to go really high, and as it approaches it from the positive side, it's going to go really low. So looking at this right here, we can talk about this later. This is more of a pre-calculus topic, but this is kind of cool. It's going up forever and it's going down forever, and it's like two opposing ideas right there. All right, guys, that's it for now for this section. Go ahead and complete your work. I'll post it in eCadence.